Welcome to One Chemistry. In this video, we are going to see Sharpless Asymmetric Epoxidation. It is a diastereoselective synthesis as well as enantioselective synthesis. It is a very important naming reaction. I provided shortcut and solved the problems. Stay tuned. For your quick reference, I given a table which is depend on OH position and reagent DET. We will see shortly, and OH position here is critical, and epoxidation happen only in allylic alcohol, and trick to find final product is para, meaning plus DET alcohol in right side above the plane epoxide. This information help you to solve the problem as well as it will help you for quick revision. Better you memorize this. First, let us see what is Sharpless asymmetric epoxidation. Basically, the starting material is allylic alcohol. It can be substituted or may not be substituted. Reagent is titanium isopropoxide and peroxide. You are having DET. If you have minus DET mean epoxidation happen above the plane. If you have minus DET mean epoxidation above the plane, plus DET mean epoxidation below the plane. This will depend on OH position also. We will see that shortly. Here the role of reagents are oxidant is peroxide, catalyst is titanium isopropoxide. Chirality of the reaction created by the reagent DET, it acts as a ligand. The whole reaction sometimes called as asymmetric epoxidation, enantioselective synthesis or diastereoselective synthesis. It's a very important one. Learn the basics. Here the reagents are bulky. Even without knowing reagent structure, you can answer, but better know it. Allylic alcohol means simple allylic position alcohol. The peroxide is tertiary butyl hydroperoxide. In simple peroxide, tertiary butyl group. And DET, it can be plus and minus. Plus and minus decided by configuration of 2 OH. If both are R mean plus DET, both are S mean minus DET. Basically, DET means diethyl tartrate, ester of tartaric acid, and titanium isopropoxide is the coordination compound. Titanium with 4-isopropyl alcohol. So better you know the reagent before master the Sharpless synthesis. Here DET decides the final product. Let us see the mechanism. Mechanism is very debatable because of bigger molecule. Here I given simpler one. If it is minus DET, it approaches alkene from top side of the alkene plane. Alkene is sp2 hybridized. It is planar. Minus DET approach from above, that is called C phase. Plus DET attack from below plane, that is called re phase. Both will create one epoxide above and below. Here product is controlled by anchoring group OH and DET, because DET approaches OH catches the group. You need not to know the mechanism, just go step by step to find the product. First step of the identifying the product is just bring the double bond vertical. In reaction, double bond may given as horizontal position. You rotate to bring the double bond vertical. While bringing vertical, OH should be above. Then find OH is left hand side or right hand side. So plus DET OH decide the final product. Plus DET OH right mean above the plane epoxidation. OH left mean below the plane epoxidation. In minus case reverse, OH right mean below the plane epoxidation. OH left mean above the plane epoxidation. This table sometimes confuse you, so I given a trick to memorize. The trick is para. Since plus DET alcohol right side mean above the plane epoxide, I just taken the first letter of the fact, create the shortcut para. So once you generate one input in the table, then derive the other possibilities, find the final product. The best way to learn the chemistry is to solve the problems. Problems are best way to learn, best way to understand the concept. The first example I given is alkene, which is allylic alcohol. Substitution of methyl and CH17. You are using peroxide, 4 mole of titanium isopropoxide, 2 mole of DET, CH2Cl2 as a solvent at minus 10 degrees Celsius. You should find what will be the final product. Here we will go step by step. Our first step is bring the alkene vertical. Once you bring alkene vertical, OH above, clearly see OH is on left hand side. Here DET they given plus 1. So if you look at the table, plus DET OH left mean below the plane epoxide. So you draw epoxide below the plane using the dotted structure. The concept you have to learn here is without the table you cannot find the final product. Better memorize the table. Then the next example, here you have cyclohexene, side chain you have alcohol, you are using peroxide minus DET, titanium isopropoxide. You should find what will be the final product. Here you have alkene. If you look at it, it is allylic alcohol. So definitely Sharpless asymmetric epoxidation. For that, we have to bring alkene vertical OH above. The starting material already has alkene vertical. OH is on right side. You are using minus DET. So if you look at the table, minus DET OH right side means below the plane epoxidation. So you draw stereochemically dotted structure oxide, that is epoxide. The concept you have to learn here is you have to master in identifying the allylic position. Always allylic position Sharpless asymmetric epoxidation happen. Then the next example, you have linear compound with 2 alkene, 1 OH is on terminal. You are using plus DET, titanium isopropoxide, peroxide, dichloromethane. You should find what will be the final product. Here 2 alkene is there, so regioselectivity, only allylic alkene will react. So to get into our final product, we'll go by the basics. First bring the alkene vertical, then find the position of OH. If you look at it, OH is on left hand side. You are using plus DET. So plus DET, OH is on left hand side mean if you look at the table below the plane epoxidation. So draw the alkene allylic position. So alkene in the allylic position, epoxidation happened. It is below the plane epoxidation. The concept you have to learn here is only allylic alkene reacts, not the isolated alkene. Then the next example, you have cyclohexane. Substitution, you have 2 methyl group, alkene, side chain alcohol, minus DET you are using titanium isopropoxide, tertiary butyl peroxide. You should find what will be the final product. Here by looking at the reagent, you might guess it is Sharpless asymmetric epoxidation. First step is bringing the alkene vertical, OH above. Already reaction has alkene vertical, OH above. OH is on left hand side. Then minus DET is given. Minus DET, OH left hand side mean if you look at the table, the epoxidation happen above the plane. So draw the epoxide above the plane with solid structure. You have above the plane epoxidation. The concept you have to learn here is whatever the starting material will be, you should always focus on basics and write the final product. Then the next example, you have linear compound with alcohol, alkene and side chain. You are using tertiary peroxide minus DET, titanium isopropoxide. you should find what will be the final product. Here by the reagents and allylic alcohol, you might realize it is diastereoselective synthesis Sharpless reaction. First step will be bringing the alkene vertical OH above. Already structure has alkene vertical OH above, which is on left hand side, and you are using minus DET. If you look at the table, minus DET OH left hand side mean epoxide happen above the plane. So the solid wedge structure draw the oxygen alkene to epoxide above the plane. The concept you have to learn here is here starting material given for confusion like trans structure, but you always focus what is basics. Bring the alkene vertical OH above plus DET or minus DET. Find the final product.